Hey London, back with another stats video going over binomial distribution and normal approximation to binomial. Um, this is, I guess, chapter 14. I don't think there's a real textbook, but this is just going to be what I'm going over today. Um, so step one is being able to recognize if a scenario is binomial or not. Uh, an easy way to know it is just looking at how many different possible scenarios there are. If there's only two possible scenarios, it's a binomial. The most common one you'll see is coin flips, that heads or tails. You can't get anything else. Um, your equations for the mean and standard deviation are also listed here. Mean is equal to n times p, and standard deviation is equal to the square root of n times p times 1 minus p. Um, Now, I'm pretty sure. I'm just Googling. Yeah, n is the number of trials that you're doing. So an example is if you do 50 coin flips, what are the chances that 20 of them are tails? Um, so n is going to be 50, because you're doing 50 trials. It's the total number of times of coin tosses. And then P is going to be um, zero point 0.5 because you can only get heads or tails. So when you're doing binomial stuff, P is almost always going to be 0.5 because it can only be one thing or the other. And usually those two things, there's an equal chance of it happening. Uh, so yeah, in this example, like in 50 trials, most the average number of heads is going to be 25 because 50 times zero point 0.5 is 25. Next up we've got being able to calculate the probability for a simple binomial scenario. Okay, so to find the probability of an exact success, there's this very long and complex formula. So in this example, let's just say that we're trying to find out um, what was the first. Oh, yeah. So, um, shoot. 10, sorry, 30, you do 50 coin flips and 30, exactly 30 are heads. So, our formula is going to be P times X equals K equals N over K times P to the K times 1 minus P to the N minus K. Just double checking that. Yeah. So it's going to be the formula. So in this example, we're trying to find within 50 trials. So n is going to be equal to 50. the number of heads there are. So that's what K is. K is for when you're trying to figure out something's exactly. So in this example, let's just say exactly 30 heads. And then P is the probability is going to be 0.5 because there's a 50% chance that there's a head. Now, using this information, try and find it out for yourself. Pause the video and I'm going to do it right here and get back to me. So equals 50 over 30 times 0.5 to the 30 times 1 minus 0.5 50 minus 30. Do, do, do. So your answer is going to be about 0.04, depending on how many decimal places Dr. Karsten wants or sig figs. I hope that's what you got. All right, on to the next thing, which is dun, 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 normal approximation to binomial distribution. All right, um, so the criteria for this for being able to take normal distribution and um turn it into binomial or vice versa. Binomial to approximating binomial distribution by using the normal distribution. The criteria for that is that n times p has to be greater than or equal to 10, and n times 1 minus p has to be greater than or equal to 10. Uh, yeah. So, um, and you'll be given this on the equation, but the equation for the standard normal distribution for finding the z-score, z is equal to x minus mean over the standard deviation. Um, the your normal distribution or normal approximation is going to be useful if you have very large n value, when you have like a bunch of trials. Um, and p is going to be, 0.5 usually. So if you have a lot of coin flips, instead of doing that long, ugly equation, you can just do the z-score method, and it's a lot easier. Hope you like this video. Hope to see you next Monday. See ya.